All right, so hey, I guess this is my first video lesson. It's really kind of a practice round, but it's on a topic that's um, kind of difficult for you guys. So I wanted to go over it and try to get it uploaded and see how it works. Gotta say, I'm pretty nervous about doing this. I could teach in front of kids, in front of adults, but being in a room just in front of a camera, it's really awkward. So I don't know whether to start this as like a episode of Hee Haw or Sesame Street or In Living Color or what, but we're gonna try this and see how it works. And if it doesn't work out real well, then I guess we'll just delete it and do it again. So, what we're going to talk about today, and hopefully it's recording everything that I wanted it to, is volume. Okay? And volume is the amount of space taken up by an object. All right? A lot of times people get confused about volume and mass. They want to say mass is the amount of space taken up by an object, or they want to give the definition of mass, which is the amount of matter in an object, for volume. But volume is the amount of space taken up by an object. Most often, the one we're talking about when we're talking about volume is liquid volume. And the base unit of volume is the liter. So you're probably most familiar with the liter when we're talking about soda or something of that nature. And here in the United States, we use the metric system, or in science we use the metric system, but um, commonly we don't. We talk about ounces and things like that, but in science we refer to volume, liquid volume, by the liter. So one thing that we use to measure liquid volume with is the graduated cylinder. So if you don't know, which I hope you do, the graduated cylinder is this thing. And it's considered graduated because it has certain measurements on it. So these tick marks, which I know you can't see real well, measure milliliters. And so these come in all different sizes and volumes. For example, this one right here measures up to 25 milliliters, and this one measures 10 milliliters. All right, now, so one thing that I wanted to show you with this, I have a beaker here of this really cool green liquid. It is food coloring in water. This is just a plain old beaker, and if I wanted to measure out a specific volume of this, say I wanted to measure, for example, right now, I don't know if you can see it real well, but it's not real accurate because we can't exactly tell how much is in there. We can tell that it's probably about 175 milliliters, but we can't measure out exactly. So let's say that I wanted to measure out 20 milliliters of the green liquid. All right, so I'm going to pour in here. Right at about 20. Now, if you notice, which I know I'm shaking because I'm nervous, but if you look here, the bottom of the fluid sort of forms a parabola because of the bonding properties of water, it sticks to the glass. So we call that the meniscus. The right way, the correct way to measure out how much volume is in there is we need to measure out at the bottom of the curve. So if you're looking at this right now, it's probably actually not at 20, but probably at 19. And I'll show you this on paper in a second. I want to add a little bit more. So for liquid volume, like I said, we're using the graduated cylinder and we're measuring in liters. Okay. I'll put that there for right now. All right. That's for liquid volume. And like I said, the meniscus is the bottom of the curve. Let me just bring that up for you while I'm doing this here. Let's see if we can do this. Okay. So hopefully you can see what I'm doing here. Instead of writing on the board, I'm going to draw on paper with my document camera. So you got your graduated cylinder, and you'll have certain marks on it. So let's say for right here, these marks are at, let's just say it's 15 and 20. And then you'll have these little tick marks going up like so on it. All right. Now, with this, I have a different color. Sorry. Something that sticks out here. All right. So let's just say we're measuring out here. And so if this is 15 and this is 20, all right, how much does each one of these little tick marks stand for? Well, the difference between 15 and 20 is what? 5. Okay. And how many marks are there between 15 and 20? 1, 2, 3, 4, 5. So each one of those counts 1. So if our meniscus here came down to here, and all this was filled up, all right, so what would it be? So if we have 15 here, we got 16 and 17. So this would be 17 milliliters. Okay, so hopefully we see that. Sometimes, though, it gets tricky. And what they'll do is they might put something on here, say this is 10, and this one here is 20, okay, milliliters. All right, so again, 1, 2, 3, 4. All right, so now we have a difference. If we want to, how much does each of these marks represent? So with that, all right, the difference between the two numbers is 10. How many marks are there? 1, 2, 3, 4, 5. If we divide them, what does it equal? 2. So for these, this would be 12. This would be 14. This is 16. This is 18. and so on until this is 20. All right. So for this one, if we had a volume in it, say it went down to here, which I know it's right on the line there, but it would be at 14 milliliters. Okay. What about though if it comes down like so? In other words, we can just go ahead and mark all that out because we don't need it. All right. It comes down and it's in between. Let me see if I can zoom that in for you. Well, I know it had a zoom button. Well, okay, so we'll just go with what we got. I know it's got a zoom on it somewhere, but we'll just make it closer. How about that? All right. So your line is here. It's in between the 16 and the 18. So there's no mark there, but if it's halfway in between, what can we assume that it would be? You could assume that it would be in between 16 and 18, which is 17 milliliters. Okay. And sometimes it'll break it down into decimal points. Sometimes um, it can get really, really specific. But for the most part, at this level, these are the ones you're going to see. The big one is when it's counting one or two spots in value. You need to know how to calculate and tell the difference between the two. They like to throw that on the SOL a lot. All right. Okay. So back to our little PowerPoint here. So what about the when you don't have a liquid? Can you still take volume? Can you calculate how much space an object is taking up? Say this box. Does it have volume? Yeah. Is it taking up space? Yes. So can we calculate it? Yes. All right. So how do we do it? Because will it fit into a graduated cylinder? No. Only liquids take on the shape of their container. So how do we do it? All right. Well, we need our trusty metric ruler. Sorry. All right. That has centimeters and millimeters on it. And what we're going to do is we're going to take three measurements. We're going to measure the length, okay, the length, the width, and the height in millimeters. So if I'm measuring this one, let's go back to document camera. All right. So I'm going to measure this one, and I'll just write it down here so that we can calculate it. And we're going to use that formula that I showed you just a second ago of volume of a solid is length times width times height. Okay, so we take and we measure out, and I don't know if you can see this, if I need to pull it up a little bit, but make sure when you measure with these, see that little bit on the end right there? You probably see it better with the white. All right, that's not measuring anything, that's just extra plastic at the end. So make sure you're using the metric side first of all. And so this right here is about, let's just give it a length of 13 times the width which is also 13 times the height, which is 2. Okay, so I switched pens and colors on you right there. Now I wish I was good enough to just do this in my head, but I'm not. So it would be 13 times 26, which equals, let me get my phone. $338 cubic centimeters. Why is it cubic? Because all of these were in centimeters. Okay. So that's right there how you take that. All right. Now, so we got right there, we got the volume of a liquid, we got the volume of a regular shaped solid. So let's see now, what about something that's not a regular shape, like a sphere or a circle or a box or a cube? Okay, what about something like this paperclip? Or what about if I took I wanted to know what the volume is of that piece of tin right there, or all of that tin in my hand. All right, could I get that? Is it possible? Or what about if I wanted the volume? I want to know the volume of one of these. Good old Abe. Honest Abe. What's your volume? Okay. Could I do that? It's not a regular shape. I mean, well, it's a circle, but there's raised surfaces, and we'd be accounting for a lot. And there's other ways to do it. You can use calculus, but there's an easier way. And the easier way is a method we call displacement. So if you remember back, we had this, and we had it out to about 20 milliliters. So if you're like me and you take, every now and again, you take a bath and you run your bath water, and then you decide that you're going to get in, you can't fill it all the way up to the top, right? because what happens if you fill it all the way up to the top and then you get in? Yeah, it'll overflow. And what's happening is you're displacing the liquid, right? So the same thing happens here with a penny. So if there's 20 milliliters in here right now, and I put this penny in, is it going to remain at 20? No, it's going to go up, right? So if I put the penny in, and you have to get it fully submerged, right? It raised up exactly 1 milliliter. So what then is the volume of the penny? It went from 20 to being 21 when I put the penny in. So then the volume of the penny is 1 milliliter. All right. Can we do that with Mr. Paperclip? Well, let's see. I've got smaller graduated cylinder and went up too much, so I'm trying to measure out. Let's just go ahead and do 6. Oh, too high. And went down, so got a better idea. Another instrument we're going to be talking about is the pipette. So, pipette describes small amounts of volume or small amounts of a liquid that we can transfer from one place to another. So, with this, I can depress the bulb and get some liquid in it and drop in about exactly what I need, which was about half a milliliter. All right. So right now, if you can see, hopefully, it's about at 6 milliliters. Well, the bottom of the meniscus is a little bit off, so let's see if we can get it to be perfect. Okay. So with this one, I'm going to try to get the volume of this guy because it definitely doesn't have a regular shape. All right, but it is a solid and it does have volume because it takes up space. So if I want to get the volume of paperclip, fill it up, and what you know, it wouldn't go in. So let's cheat a little. You're gonna bend it up, reshape it. Sorry. So let's try this. Tip 2. Again, it didn't work. All right. technical difficulty. All right, third time's a charm. Here we go. All right, so it went in and it raised up about 2 lines. Okay, so that brings up another good point with this, and let's go back to we're already on the document camera. So with this one, it's the volume readings are so small, okay, that it actually is measured out by one place. So what I mean by that is that this line, the big tick mark, is a 1, and the next one is a 2. All right, so, and if these are whole numbers, we can assume they're the same thing as 1.0, 2.0, and so on. All right, so if we take about halfway here, that would be what? Well, between 1.0 and 2.0 is 1.5. All right, so each one of these little marks then would be one decimal place. So this would be 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.7, I mean 1.8, 1.9, 2.0. Okay? So with the last one, it was at not 1.0, but 6.0. So this would have been 6.5, and that would have been 7. So after I dropped in the paper clip, it raised. All right. So originally it was here, and just based on my reading, it raised up to here. All right. So it raised up that much right there. So what's the difference then? So if this is 6.2 and it was originally at 6.0, then the volume, the difference is 0.2 milliliters. So then a standard paper clip has about a volume of about 0.2 milliliters. All right, so we go back to your PowerPoint and your notes. You can see here that we went through all the way down through irregular shaped solid, and we use the method called displacement. So I just wanted to take today and try this out with you guys and see how it worked out. And I'm gonna go back and review and nitpick myself. And like I said, I'm nervous. I feel like I could talk in front of you guys for days and not have problems, but I guess we're all our own biggest critics, and so I feel really silly just talking to myself and to a pretend audience, and um, watching myself on the little picture in a picture there. Keep wanting to call for makeup or something. So anyhow, um, stay classy, Tazewell. Goodbye.